Hi everyone, welcome to my channel. I'm a Kaggle master and junior data scientist. Guys, in this video we have discussing about evaluation metrics for the machine learning models. Why evaluation metrics is important, when and where we use evaluation metrics, and which types of evaluation metrics available in a classification problem as well as in a regression problem. So let's start with the machine learning. There are three types of machine learning. First, supervised machine learning. Second, unsupervised machine learning. And third is the reinforcement learning. Let's understand one by one. So, in a supervised learning, when we have a past data with the outcomes and you want to predict the outcome for the future, then we will use a supervised machine learning algorithm. Supervised machine learning problem again divided into two parts. First is the classification problem. Second is the regression problem. For the classification problem, when you want to classify the outcome into a different classes, let's take one example for the Titanic dataset. In a Titanic dataset, we have to predict the person is a survived or not, yes or no, or 0 or 1. So in these types of problem, we have used a classification problem. Let's come into the regression problem. When you are interested in answering how much answering, okay, answering how much. So let's take one example with a house price prediction. In a house price prediction, we have want to predict the particular price of the particular house. Okay, so in these types of problem, we have used a regression problem. Okay, next let's discuss with the unsupervised machine learning. There are times when you don't want to exactly predict an outcome. You just want to perform a segmentation or clustering. For example, a bank would want to have a segmentation of its customers to understand their behavior. This is an unsupervised machine learning problem, as we are not predicting any outcome here. Okay. Next, coming to the why we use a evaluation matrix. Guys, simply building a predictive model is not our motive. In a data science problem or a machine learning problem or any AI industry problem, only building a model is not our motive. So it's all about creating and selecting a model which gives the high accuracy on out of the sample data. Hence, it is a crucial to check the accuracy of your model prior to computing predicting values. In a classification problem, we categorize the target variable into a finite number of different classes. While in a regression problem, the target variable has continuous values and we try to get as close to these values as soon as possible. Okay, so only simply building a predictive model is not our model. We have also checked our accuracy. Okay, let's next discuss with the which types of evaluation metrics is available in a machine learning program like a classification problem in a regression program. So there are many types of confusion metrics, evaluation metrics available in a regression problem as well as a regression problem and classification problem. So in a classification problem, we have mainly used 7 types of evaluation metrics like confusion matrix, accuracy, precision and recall, AOC, ROC, FS score, alternatives to accuracy, and log loss. In a regression problem, we have used a mean square error, root mean square error, RMSC, MAE, mean absolute error, RMSLE, root mean square, log error, adjusted R square, and R square. Okay, so let's start with the one of the classification evaluation matrix. We have to start with the confusion matrix. So confusion matrix is a n into n matrix where n is the number of classes. Confusion matrix is the n into n matrix where n is the number of classes being predicted for the problem. In hand, we have n is equal to 2 and hence we get a 2 into 2 matrix. So I just first of all for the this is our n into n matrix. I just defining this is your n into n matrix, where n is the number of n is equal to n is the number of classes. Okay, so let's start with the confusion matrix. I just define you a formal way of representing a predicting by a classification model and the actual value in the dataset. For this purpose, we need a confusion matrix. The word confusion might be there in a name, but don't worry, it's easy to understand when you understand the intuition behind the confusion matrix. Let's take a simple example with a dataset. I just take a Titanic dataset for the Titanic dataset. Okay, I just take our dependent variable in a Titanic dataset. So in a Titanic dataset, our dependent variable is the like a 0 and 1 for the 0 0 1 1 1 0 1. Okay, so let's start with the dummy dataset. I just take a one of the Titanic dataset. In a Titanic dataset, we have a dependent variable 0 and 1. Only two values are available. Okay, 0 and 1. It represents the people survived or not. It represents people have survived or not. So in the Titanic dataset, our n is equal to 2 because 0 and 1 only two values are available. This is our binary class classification problem. Okay, so only two values are available, and our confusion matrix form will be a 2 into 2 matrix. So our confusion matrix is the 2 into 2 matrix. Okay, for the this is our actual value, sorry, this is our predicted value, predicted values, and this is our actual value, actual values. Okay, for the actual value, this is positive, this is negative, this is also a positive, and this is negative. So positive plus positive is positive. Okay,